Hello everyone! We are starting a free open lecture on our Discord. All our lectures are held weekly without breaks. If you, the viewer, want to ask questions and get answers in an online format, join our lectures. You can find the link to our Discord in our Telegram channel. To find out the lecture times, join our Telegram channel. This is what we have learned to do. Now the question is, how do we take and assemble a palindrome? Let's say we have such a mapping of characters. We took a given string, built a character mapping from it, where the key is the character itself, and the value is how many times this character occurs. Well, then we immediately checked whether it is possible to build a palindrome from this string or not. This is what we were just talking about. And now, how to build a palindrome. The last question, how to build a palindrome. Let's not focus on making it lexicographically minimal for now, but just any palindrome. Well, first of all, if we have a string that is of even length, then what will we have accordingly? Here we have some sequence of characters t, which is indeed, in fact, actually, right? Then here we will have the middle of the string, and here is the same sequence of characters t, but in reverse order. That is, we essentially take each character and place it at the beginning once, then place it at the end. If this character is still there, we place it at the beginning and end again, and so on. Let's say it ended, we can take the second one here, the third character, and so on. And we will definitely get a palindrome. Now, how can we absolutely make this palindrome lexicographically minimal? This means that at the very beginning, we should have the letters that come first in the alphabet. That is, it's A, B. If we take the alphabet, there are A, B, C, D, E. So accordingly, the first should be A, the second B, the third C, and so on. If they exist, of course. And for example, I made this palindrome lexicographically minimal because I have an A at the very beginning. And essentially, this minimality is determined by the first half. Since the second half will be mirrored in any case, this does not affect anything. This is the case with even strings. Have we figured out how it will look if our string is odd? Basically, it's the same, but we have one character that will be in the middle. That is, in other words, here it will be essentially the same string t. It will be, here I will have some character that is left alone, for example, this b, and it will stand in the middle accordingly. And since it is alone, it is again lexicographically. Do you want to become a cool programmer? Subscribe to our Telegram channel, because again, this symbol won't fly anywhere, it will remain the only one, and its place will be only here. Therefore, the lexicographically minimal thing is candles. It is built only based on the first half.
Want to become a great programmer? Subscribe to our Telegram channel.
Well, what should we try to do now? I already mentioned that we need to consider the naive solution, and we will try to optimize this naive solution a little bit. Let's say, hypothetically, what a naive solution would look like. So we have a segment, and let's say we need to make a palindrome out of this string, right? How will we implement the naive solution? We take this substring, iterate through it, and then simply accumulate the frequency of each character in some kind of map in order to basically, essentially, in a straightforward manner, achieve our goal. Here we placed A1, then the next A will be 2 here, then B1. For example, in this particular scenario, as you can see, accordingly, we will later check using this map whether it is possible to form a palindrome from this string, and then we will simply assemble it in this order. We will place A here and there, and it ended. Then B was the only thing left. It is in the middle of the building. So, in the worst case, we will do this with a complexity of ATM. Now let me explain how I started reasoning further. Is it possible to make more efficient this operation somehow in any way? Well, you can't immediately say that a segment tree or some other data structure is being used, which is in fact efficient for range queries. So I actually started thinking here if this operation could be optimized using such a structure, because it seems like a problem about segments, like maybe this will help me, well, at least in solving this particular issue. What will I come to? Well, I can just take the whole string and sort of basically change each character to itself. So I have this string, which is ABCBA. What will it represent? So how much will it be? 1, 2, 3, 7, I think, right? So I ended up with a segment tree. I will have 8 nodes. And so my first one is A. A appears once, then another A. It also actually occurs once, then B. I am in fact writing out the string itself. Each character for me will not just symbolize a character, but rather a mapping of that specific character to its frequency count. B1, C1. What will we do next? We will merge sets together. That is to say, we shall create a segment tree structure where the element is a set of maps, and relying on the tree will result in the merging of 2 maps. Essentially, this is the plus operation. So, what kind of merging is it? For example, into what will these 2 nodes merge? They will merge into a set where the key will be A, and the value will already indeed be 2. That is, we take the same key and add the value. Therefore, this is another node. Here we will get a detailed map with B as one node and C as another node. And what will the root node look like? It will be A, which is the starting point of our map. 2, for example, B1 and C1. This is somewhat similar to a merge sort tree in terms of the construction principle. And if I set up such a segment tree, quite ordinary, then I will basically be able to quickly respond to this query. What query? Essentially, can I construct a palindrome on some segment, and how would I make this palindrome? In principle, I can do it too. So, what can I do? Here, I will get a set of all characters in my substring in logarithmic time, at n in logarithmic time, sum t. So, I basically transform this substring essentially into this kind of map, in a way. That's it. Accordingly, if I have it here, in the worst case scenario, the length of this particular substring will be n, because if I place L and R at the extremes, then the length of such a specific map will be fixed. It will be what? Approximately 26. Accordingly, here I immediately switched from some large variable. The size is reduced to a small constant, and then accordingly, I can run through this string, or rather, the map, in 26 operations, and find out whether I can construct a palindrome or not. This is the first optimization that allows me to do it with what complexity? Well, actually, 26 is a constant because we are also going to merge the segment tree here. And the merging will occur in approximately 26 operations in total, in the worst case scenario, which is the most extreme situation, indeed. And the number of such operations using the segment tree will be no more than the logarithm of at. And accordingly, we immediately move to the logarithm. And essentially the first part seems to be ready. We can quickly and efficiently check whether a palindrome can be constructed from a substring or not. But now here comes the second part, and here's how to quickly construct a palindrome as well, preferably with an algorithm. And it will kind of look like an operation on a certain segment of the data in a way that essentially resembles a lazy segment tree operation, like when we use a lazy segment tree, which is a data structure used for range queries, and on some segment we will be setting a specific value. Let's consider for a moment our lazy segment tree. It also allows, with the algorithm, to add some value to the entire segment, multiply all values in these segments by some x, and also, let's say, the assignment operation works as well. We can assign some value, say x, to the entire segment like this. And the only thing left is to implement this function and the object of this lazy assignment so that the structure of the segment tree does not fall apart.
Want to become a great programmer? Subscribe to our Telegram channel.